Okay, let's get it going. In this new unit, we are still talking about the triangle. A lot more facts about a triangle, different lines inside a triangle. As far as proofs goes, there will be a couple at the very end, but it's not very heavy on proofs like the last unit was. But I still see even top students go downhill in this unit. And the reason is there's a ton of new vocabulary. So I don't know if starting today, after today's class this weekend, you want to start making your own index cards up with all this new vocabulary, but there's a ton of new vocabulary you have not heard about. And that's when it starts snowballing on people and they never catch up. So even the best here, watch out in this unit. All right, here we go. First vocabulary term right off the bat is what are called concurrent lines. 3 or more lines all intersecting at a point. That's what I'd like you to draw me right now in this box right now. 3 or more lines that intersect at the same point. I don't care how many lines you have, but it's got to be at least 3. 3 or more lines that intersect at the same point. Those are referred to as concurrent lines. There are 3 lines, and they all intersect at the same point. That point that they all intersect at, please make a point, very obvious point that they all intersect at. That point we're going to refer to as the point of concurrency. All right, the point of concurrency, where they all intersect. So I'll just let that sink in now because the vocab's coming strong and fast today. So 3 lines that all intersect at the same point, concurrent. That point that they intersect, it's called the point of concurrency. We all good? All right, now let's start talking about a triangle and a circle. When I have a circle that's drawn around a triangle, a circle that's drawn around a triangle. So go ahead, make a triangle in that box for me. And please make a circle around it so each vertex touches the circle. You don't need a compass or anything. Don't need a straight edge. We're just freehanding this. Draw a circle around that triangle so that each of the 3 vertices are being touched on the circle. Okay, we all good? Everyone have a triangle inside a circle where the vertices are touching the circle. That circle, we say, is being circumscribed around the triangle, meaning the circle, the circumscribed part tells me it's on the outside. All right, the outside of the triangle. So the circle is circumscribed around the triangle on the outside. Well, what if I put the circle inside now? So go ahead, draw a triangle again for me in the 3rd box. Draw another triangle. And place a circle inside. So this circle touches each side of the triangle, please. Okay, put a circle inside that touches each side of the triangle. Now, because the circle's inside, not outside, I don't want to call it circumscribed anymore. We have a new term for it, which is called inscribed. Inscribed sounds like the word inside, meaning, yes, the circle is inside the triangle now. When I say circumscribed, that means the circle's on the outside. Questions? We all good? Concurrent? Circumscribed versus inscribed. Inscribed inside. The circle is inside. All right, here we go. Go ahead and graph that next triangle for me. We got a lot of work to do. Graph that next triangle. I'm going to ask you to do a couple things you already know how to do with this triangle. But I don't want, it's going to waste too much time if we do every single one together. So I'm going to divide you guys up into 3 groups. This section right here is going to be group 1, middle section right here, group 2. This 2 groups over here are going to be group 3 over to the right. Okay? Please just do your job, not any other group's job. First thing I want to find is the midpoint of each side. I'm not giving it to you. We've gone over midpoint a lot already this year. You either look it up or you ask people in your group. Group 1, you guys got the midpoint of AC only. Group 2 in the middle, you have the midpoint of BC. And then group 3, you guys have the midpoint of AB only, please. All right, go ahead. About a minute right now, it should take you. Find the midpoint. Again, somebody look it up. Or if somebody knows it, tell your group members. Midpoint formula. Find the midpoint of each of your sides. Okay, we got to get moving. Add your x's divide by 2, add your y's divide by 2. Here we go. Make sure you write down what every other group has. Group 1, what'd you got? I don't care who reports back. Midpoint of AC, 4, 1. Can everyone call that point D for me? 4, 1, the midpoint of AC. Group 2, what'd you get for the midpoint of BC? 8, 2. Can you please call that point E, everybody? 8, 2, midpoint of BC. Group 3, what'd you get for the midpoint of AB? 5, 4. Can you guys please call that point F? And then take about 30 seconds right now and graph all 3 points D, E, and F right now. Do not connect them, just graph them. Do not connect them, just graph them. And label them with the correct letter. And hopefully they're landing right on the sides, which we hoped. Okay, thank you for finding the midpoints. Now, same thing, but I'm going to ask you to find something different for your line segment. All right, so if you turn the page right now, you'll see I don't want the midpoint anymore. I'm asking for your segment's slope and what would be the slope of a line perpendicular to it. All right, so I'm not going to say a word. Group 1, you still got AC, so find the slope of AC and the slope of a line that would be perpendicular to it. Group 2, you guys still have BC. Group 3, you still have AB. If you want to use rise over run or the slope formula, that's up to you. All right, another minute. Go ahead. Find the slope and the slope of a line that would be perpendicular to it. And please make sure it's in lowest terms too. Reduce your fraction for me, if you can. Okay, let's move. As you can see, we're going to go quick here today. Group 1, slope of AC. I don't care who's going to report back to me. Slope of AC should be -2/3. Meaning any line that's perpendicular to AC will have a slope of +3/2. Negative reciprocals. Group 2, what'd you find the slope of BC? Should be 3, yep. Meaning any line that's perpendicular to it will have a slope of -1/3. Okay, group 3, what do you got for me? Slope of AB? 1/4. So any line perpendicular to it will have a slope of -4. All right, now here is where you're going to need your straight edge, because now we're going to combine the whole midpoint and slope thing together on your graph. Here's what I need. I need and take a look, I need to draw a line that's perpendicular to each side but going through its midpoint. All right, so again, let me say that a little bit slower. I need to every side, I need a line that's perpendicular to that side and going through its midpoint. So I'll do AB with you. AB's slope was 1/4, but we said if I want a perpendicular line, what's the slope got to be? -4, and it's got to go through F. All right, so going back to algebra last year when you guys graph points, if I start at F and I know my slope has to be -4, where can I go from here to get a slope of -4? There's a couple ways I could do it. Cameron? Down 4 and right or left 1? Down, ready? Down 4, 1, 2, 3, 4, to the right 1. Or you could go up 4, 1, 2, 3, 4, and to the left 1. You need your straight edge now to draw in that perpendicular line. There are a ton of protractors up here. It's not an excuse if you don't have one. Pick another side. So let's go BC now. What's the slope of a line perpendicular to BC? -1/3, and it's got to go through E. So where do you suggest I go from point E? I can go down 1, right 3, 1, 2, 3, or I can go up 1, left 3, 1, 2, 3. Straight edge, graph those lines in, please. And then the last one for DC, or AC, AC, got to have a slope of 3/2 going through point D. Got to have a slope of 3/2 going through point D. Where should I go from point D? Up 3, 1, 2, 3, right 2, 1, 2, 3, right 2, or I could go down 3, left 2. Please have all 3 lines graphed in. Do we have all 3 lines graphed in? Ready to move on? Because we need to answer some questions now. All right, moving on. Those 3 lines you just graphed in, and if you got to look back at the definition, go back and look again. Are these 3 lines that we just graphed in concurrent? What's it mean to be concurrent again? Let's get up on our vocab now. What's it mean to be concurrent? They all intersect at one point. Go and look. Did those three lines intersect at the same point? No. Everyone else's, yes? Okay, so these three lines, we got to move, guys, here. Are these three lines concurrent? Yes, they are. Okay, I don't want to call them these lines anymore. You have a vocabulary term we have gone over multiple times this year instead of calling them these lines. Ready? This line is what to BC? Perpendicular, and it goes through the what? Midpoint. Perpendicular, and it goes through the midpoint of that side. These aren't these lines anymore. What are they? Perpendicular bisectors. We just graphed perpendicular bisectors. 3 of them for all 3 sides. And what did we notice? They all intersected at the same point. So our conclusion is all 3, what do we call them again? Perpendicular bisectors in a triangle are, and I don't want to use the word they intersect anymore. What's our new vocabulary term? These perpendicular bisectors are concurrent. And we found out earlier, if you got to look up the vocabulary term again, the point where they intersect, what do we call that point? The point of concurrency. But now that I know it's the perpendicular bisectors, that point of concurrency is going to have a name now, an actual new vocabulary term. When it's the perpendicular bisectors that are concurrent, that point they intersect at is called the circumcenter. The circumcenter. That's where all 3 perpendicular bisectors meet in a triangle. All right, again, all 3 perpendicular bisectors in a triangle meet at what's called the circumcenter. That sounds very, very familiar to what word we already went over today. Look back if you need to. Circumcenter, circumscribed, right? What did circumscribe mean again? The circle was outside. Watch and learn. Everyone, take your compass right now. Go back to the graph. Watch this magic right now. What did circumscribe mean? It's on the outside or inside of the triangle? Outside. Ready? Put your compass point on the circumcenter of your graph. Put it on the circumcenter. Put a pencil point on one of the vertices. Draw it around. Watch the magic happen as you get a circle on the outside of your triangle. Again, put your compass point on the circumcenter. Put the pencil point on one of the vertices of the triangle. Draw a circle around it, circumscribe it, and watch it hit all the vertices if you found the circumcenter correctly. Should come pretty close to hitting all 3 vertices. Exactly. All right, everybody good? Because we're not off this circumcenter yet. We still have one other thing we need to talk about before we move on from it. Circumcenter, all 3 what? Intersect. Let's not call them lines anymore. Perpendicular bisectors intersect. Okay? By the way, we're going to have 4 of these, by the way. 4 of these new names. And we got to know how they're formed. Circumcenter, all 3 perpendicular bisectors. We all good? You guys that are making the circles, we're going to have to finish them in a little bit. So we got to move on. Okay. What you have to know about the circumcenter. One and only one fact. that point, everyone ready, equidistant from the vertices of the triangle. Okay, equidistant from the vertices. So what I want you to do right now is just randomly draw a triangle for me, right below that theorem, or somewhere near it. Put a point somewhere in that circle. Doesn't have to be right in the middle. Put it anywhere. We're going to assume that that's our circumcenter. What does this theorem say? From that point, please draw a line segment to every vertex of your triangle right now. Please draw a line segment to every vertex of your triangle from the circumcenter. This new theorem says the following. That point, same distance away from every vertex. So those line segments you just made are all congruent. Circumcenter only, equidistant from the vertices. We okay? Because now we're going to apply it, and now you're going to start talking. Okay, this first one, I gave you triangle ABC. Find the circumcenter. Find the circumcenter. All right, I'm not going to let you go on your own. We're not ready for that yet. There it is. Okay. Let's go. 4. How is the circumcenter found? By finding the intersection of the what? Who's got 4? There you go. So I see circumcenter. I start saying, all right, I need to find where the 3 perpendicular bisectors are. So that's our job right now. Take each side and find the perpendicular bisector for each side. Let's start with BC, everybody. Start with BC. Bisects means it's got to go through its midpoint. Can we find the midpoint of BC pretty quickly without even using the formula? Well, how long? Where everybody count? How long is BC? 8. So where should the midpoint be located? Halfway. So go ahead. Put a little point where the midpoint should be. 1, 2, 3, 4. Right here. Here's the midpoint. 4 away from each. Now let's go to the perpendicular part. What type of line is BC? And do not say straight. BC. Horizontal. What's always perpendicular to a horizontal line? A vertical line. Can you draw a vertical line in going through the midpoint? Because you've just made a perpendicular bisector. There it is for BC. There's the perpendicular bisector. We still have to do 2 more sides, right? Well, what's going to be another easy side to do real quick? AB. Here we go. How long's AB? It is also 8 units. So the midpoint's going to be 4 units away. And this is what type of line, AB? Vertical. What's perpendicular to a vertical? Okay, draw it in. There's the other perpendicular. I got 2 out of 3. Everyone with me so far, drawing those 2 perpendicular bisectors. What's going to be the pain in the butt? AC, because it's not horizontal or vertical. But let's stop right here, please. Let's stop and think about this. Is it necessary for me to do the third one? Don't I know where it's going to intersect? Where the other 2 intersected, right? Everyone agree? I know if I did these 2 right, the third one for this one better intersect right there. Because all 3 need to intersect at the same point. So is it worth it doing it? No, absolutely not. I only need 2. There it is. Where the perpendicular bisectors meet. And then it says find the coordinate. So name that coordinate where they met. What do we got, 13? Name the coordinate where they met. I think 1, 2, 3, 4. I have 5 on the y-axis. Over 5, up 5. Some of you are saying, well, shouldn't it be 4? Hey, go from the origin. You guys are counting from point B. If you're telling me it's 1, 2, 3, 4, you got to count from the origin when you find a point. All right, count from the origin. So are we okay on that? When you have horizontal and vertical lines, the perpendicular bisectors are very, very nice. If not, I got to do it the way we just did in all our groups there before. All right. Questions? All right, one more Circumcenter question. Take a look at this one. See if we can find a solution to this one, because it's not on a graph anymore. Not on a graph. I got a stove, a sink, K, refrigerator, R. I want to put an island somewhere where it's the same distance from all 3 points. So somewhere up here, I got to put I don't know. I don't know. I got to put a point somewhere up here that's equal distant away from K, R, and S. What's the purpose of the Circumcenter again? What's the one fact that you got to remember about a Circumcenter? Look back if you need to. Let's not just stare at each other. Look back if you need to. That's the only way we're going to know this vocab. What's the one theorem I need you to remember for a Circumcenter? Go ahead, Nick.
Perpendicular bisectors are the sides of the triangle.
The Circumcenter is
concurrent at a point equidistant from the vertices.
Equidistant from the vertices. If I connect these 3 vertices, what do I form here, guys? Oh, a triangle, you don't say. And what's that special point going to be called that's equidistant? The Circumcenter. Here you go. So I'm going to find same distance from these 3 points. I'm asking for the Circumcenter. All right, let's go through it again. How do you find the Circumcenter? It's all 3 what? Perpendicular bisectors. Well, you're not on a graph anymore, guys. So how are you going to find the perpendicular bisectors for those 3 sides? Some of you are understanding how we're going to do it here. You're not on a graph, so how do you find the perpendicular bisector? Something we did, I think, in Unit 1. And this is why I had you bring them today. You know how to do a construction, don't you? With the perpendicular bisector. Anybody remember? Let's refresh our memories. Let's get our compass out. So let's start with KR. How do I construct a perpendicular bisector for KR? Put it on one of them. Let's go. Put your compass point on one of the endpoints. What should I do with my compass? Open it up. More than half the distance of the segment. Yep. AKA the fish. Making a decent size arc. Keep the same opening and go over to the other endpoint now. Grab your straight edge, draw in your perpendicular bisector, please. There's one. How many do we need? Do we need all 3 still? No. If you do the first 2 correctly with your compass, you should know where the intersection point is going to be. So at least do 1 more. And yes, I know it's going to get a little sloppy, but it really depends on how well you are with your compass. Leave all construction marks, please. So pick another side, open up your compass more than half the length, and do another perpendicular bisector. Shoot. Let's start that one over. And where are we going to put this island? Looks like right here I'm going to put it. That point right there is the same distance from the sink as it is from the stove, as it is from the refrigerator. And make sure you guys just make a little note that that is your island right there. Questions on the Circumcenter. It's formed by all three perpendicular bisectors. And, hold on, what's the fact I should know about it, other than it's formed by all three perpendicular bisectors? It's equidistant from the vertices of the triangle, yes. All right, hopefully we got that all good to go, because I got another point of concurrency for you. There's going to be 4 total. We just went over one of them. So go ahead and draw the triangle right there. We just worked with the perpendicular bisectors and found out they all meet at a point. Now I want to turn our attention to the angle bisectors of a triangle. All right, so this is another construction we have to review quickly. Okay, so we're going to do the angle bisectors for all 3. Let's first start out by bisecting angle C. So go ahead, put your compass point on angle C. And you want to make an arc that intersects angle C in 2 spots. Angle C in 2 spots. Okay, intersects it in 2 spots. Put your compass point on one of those points of intersection, one of those 2 spots. And draw 2 more arcs out in front that intersect. 1, 2. Hopefully it's ringing some bells. I went from each point of intersection. Take your straight edge, line it up with angle C, and draw in your bisector. And see if you can do it for at least one more angle, at least one more. And if you did a third one, because I know I didn't give you the biggest of triangles to work with, if you did a third one, guess what would happen? They would all be concurrent. They would all intersect at the same spot. They would all be concurrent. So the conclusion here, give you guys another couple seconds here to finish up. You guys already know perpendicular bisectors all intersect at a point. Now you're finding out what? What did we just construct here? Not a perpendicular bisector, but Not a perpendicular, but a... So the angle bisectors of a triangle are what? I don't want to say intersect anymore. Look back if you have to look back. If they all intersect at the same point, they are concurrent. So where they intersect, this point of concurrency where they intersect, obviously can't be the circumcenter because that's for perpendicular bisectors. This is for the incenter. The incenter. And there's 4 of these total. You just got half of them today. The incenter theorem. This is where we'll end it today. Circumcenter, it was equidistant from the what of the triangle? Circumcenter. Equidistant from the vertices. Draw yourself a triangle underneath on the bottom of your page there so I can show you the incenter, what that does. And let's just make a point in there that represents the incenter. Say we found it by doing the angle bisectors. So there's the incenter. The incenter, it is not equidistant from the vertices. Not equidistant from the vertices. Everyone ready? It's equidistant from the, if you read the theorem, equidistant from the sides. All right? So what I need you guys to do best possible is draw a segment to every side that's perpendicular. Yes, and then those segments are congruent. The incenter is equidistant from the sides, circumcenter equidistant from the vertices. Everyone, pencils down. I don't want you packing up when I'm going to be asking you guys a quick quiz right now. All right, here we go. Let's do this. Who's got 5? Okay, my first question for you. Name a type of line concurrent in a triangle. Went over two types of lines that all meet at the same point today. Name one of those types of lines. All 3 what intersect? All 3 what intersect in a triangle? Different types today. Okay, all 3 angle bisectors are concurrent. That point of concurrency where they all meet in an angle bisect, all the angle bisectors, is called the 6 incenter. Everyone good? 3 angle bisectors meet at the incenter. What's so special about the incenter? What's the special theorem about it? 10? All the sides. Nice. Okay, he gave us angle bisectors. What's the other type of line that's concurrent in a triangle? 5? Oh, sorry, you already went. Here's some new people. 17? The perpendicular bisectors are concurrent. Where they meet is called the 16? The circumcenter. What is so special about the circumcenter that we need to remember? The one fact. 13? From the vertices. Okay, those are 2. I got another 2 for you. All right, later on next week. So if you want to start making up the index cards, might be helpful to you. All right. Oh, go to your packet real quick. Assignment sheet. It's not 27 through 290 tonight. All right, I believe it's 27 through. Anybody have their assignment sheet? 29. Yes, it's 29. Okay, there's not 290 problems.